Good morning friends, I am Kshitiz and in today's lecture we are going to study physical world, chapter number 1, part 1, CBSE, NCERT for class 11th. So we will start with science. So science is derived from Latin word scientia, which means to know. In Sanskrit, science is known as Vigyan, and in Arabic, science is known as ilm. Both of them means knowledge. So whenever we are talking about physics, physics is the second most purest of all science. First most is math, and on the foundation of math there is physics. Okay, so physics right after mathematics is the purest of all science. So physics comes from Greek word physike. Physike means knowledge of nature, and physics in Latin means physica, and in old French it means physique, means medicine. So its Sanskrit equivalent is bhautiki, and as we know that physics also includes chemistry and biology. So we as a human beings are very inquisitiveness. We have the inquisitiveness in our nature, and we look for the patterns in the natural phenomena and build and use new tools to interact with nature. So whenever we are seeing some interesting phenomena around us, so we are seeking answer or the rationale behind those things. So what things we observe around us? We observe repetition of day and night. We observe eclipses, whether they are solar eclipses or lunar eclipses. We observe the volcanoes. We observe the seasons. Seasons come and go. We observe the rainbow, and we are seeking answer to our question. So answers to these questions can be provided in physics. So this is our inquisitiveness. Okay, we are marveling at many things like the night sky, and we want to interpret the cosmological phenomena. But physics is not only about cosmology. It is about many other things. So penned word evolution of physics. So physics is in the current stage undergoing many previous stages. So before 16th century, the early civilization of Egypt, India, China, Greece and Mesopotamia did the pioneering work in the field of physics. From the 16th century to mid 20th century was dominated by Europe, and the current century, by the middle of 20th century to now, the science has become an international phenomena. Means the trans-country borders have disappeared, and everybody is contributing massively to the cause of physics. So now we will talk about scientific methods. So scientific methods can be divided into 5 steps. So whenever we want to study any physical phenomena, we need scientific methods to do that study. So scientific methods consist of 5 different steps. So first step is systematic observation, second control experiment, third qualitative and quantitative reasoning, fourth is mathematical modeling, and fifth is prediction and verification of theory or refuting of the old theory. So sometimes the new theory supplants the old theory. Sometimes new theory complements the old theory, and sometimes the new theory accommodate the old theory. So new theory and old theory. So there are different permutation and combination. So as we know that science is always dynamic, there is no final theory. So in some cases new theory may suggest some modification that may not be drastic. Like there was a scientist Nicholas Copernicus. He lived during period 1473 to 1543. So he gave a theory, heliocentric theory. So according to heliocentric theory, the planets move in circular orbits with sun at the center of the solar system. So there was another scientist, Johannes Kepler, who lived during 1571 to 1630. So he also used the work of Tycho Brahe, who lived during 1546 to 1601. So he accepted the heliocentric theory of Nicholas Copernicus, but though with minor modification. He told, yes, Copernicus, whatever you told, that is correct, that the planets move around the sun, but they don't move in circular orbits, they move in elliptical orbit. So new theory is not replacing the old theory, but it is slightly modifying the old theory, like in the case of Johannes Kepler. Sometime new theory causes a major upheaval in the old theory. So sometime it happens that the modern questions cannot be answered by the old theory. So new problems need new solutions. New problems cannot be solved by old methods. So new problems need new solutions. So like there was a scientist Newton, our father of physics is same father of physics Newton, who in the beginning of 20th century gave the Newtonian mechanics. But Newtonian mechanics were not sufficient to explain the basic features of the atomic phenomena, and wave theory could not explain the photoelectric effect properly. So there was a major upheaval done by Max Planck and Albert Einstein, who gave the quantum mechanics theory. Quantum mechanics theory could explain atomic and molecular phenomena. So there was a major upheaval. The old theory was supplanted by the new theory. There was no minor correction. It was altogether replaced. So sometimes new theory supports the old theory. Like in 1930, there was a scientist Paul Dirac who gave the anti-particle concept. So two years later down the line, there was another scientist Carl Anderson who did the accidental discovery of positron anti-electron. So Carl Anderson gave theory that supported the old theory. It supported. So Carl Anderson supported Paul Dirac. So new theory supporting the old theory. So now there are two things. One is unification and other is reduction. So whenever we are talking about unification, in unification new theory support old theory in unification. Like Newton discovered principle of gravity. So gravity, he was sitting beneath an apple tree, an apple fell onto him, and he attributed the cause to force of gravity. Same gravity later on scientists were studying the motion of the moon around the earth and motion of the earth around the sun. So they did not invented gravity. They used the principle given by Newton. So that is an example of unification. In the same manner, gravity findings and relation of electric and magnetic phenomena with basic laws of electromagnetism. This is also an example of unification. So the basic laws of electromagnetism supports the finding of electric and magnetic phenomena. Okay. So whenever we are talking about the reduction, so properties and interchanges of simple constituent part lead into properties of a bigger and complex system. So microscopic properties of the thermodynamics like temperature, internal energy and entropy leads to kinetic theory and statistical mechanics. That means a small thing leading to a big thing. Okay, so we are talking about scope and excitement of physics. So we can divide the physics into two scopes. One is classical physics, another is the modern physics. So classical physics deals with macroscopic phenomena like mechanics, optics, electrodynamics and thermodynamics, whereas the modern physics deals with microscopic phenomena like nuclear physics, atomic physics, kinetic theory and so on. Okay, so talking about the scope and excitement of physics, so we need to talk about what are the variations in fundamental quantities. Variation in the fundamental quantities. Fundamental quantities are 7, but here we will talk about length, mass and time. So there are huge variation in the fundamental quantities in the space. So whenever we are talking about length, it is varying from 10 to power minus 14 meter to 10 to power plus 26 meter. 10 to power plus 26 meter is the scale of galaxies or even the entire universe, and 10 to power minus 14 meter is atomic scale. So that means the length is varying up to degree of 10 to power 40 meters. So length is varying so drastically within our universe. Whenever we are talking about mass, so mass of an electron is 10 to power minus 30 kg, and mass of the known observable universe is 10 to power 55 kg. So there is huge variation in the mass as well. And whenever we are talking about time, the variation of time is between 10 to power minus 22 second to 10 to power 18 second. So now let's move to major scientists and their contribution in physics. So there were many physicians who contributed immensely to the cause of physics. Like Indians are also there. Like J.C. Bose is there, Satyendranath Bose is there, C.B. Raman is there. Okay, they are the pioneering scientists in the field of physics. They enormously contributed to the physics. So these scientists put forwarded many theories. They put forwarded many theories. Okay, so that's all. This is chapter number 1. See you soon in our next video. Thank you. Namaste.